Again, welcome back to C++ programming language. This lecture again covers the concept of variables and also how to use arithmetic operations in C++ programming language. Also, we are going to write an example on how to evaluate an expressions in C++. So in C++ language, we have different data types. For example, we have a whole number, we have a decimal numbers, characters, strings, etc. So the example we have here is how to declare a variable. So declaring a variable, first we have to specify the data type. The data type tells us what value we can store in a variable. A variable is more or less a memory location. So here we have int I equal to 34, which means we are assigning 34 to a variable named I. And the variable name I, the data type should be int, which means we can only store a whole number. Same thing applies to long. Long also is a whole number, but long can take more larger values than int. Then we also have double. Double is a decimal number. So here we can see that when we declare a variable named b, the data type is double. Instead of assigning 5, we assign 5.0 because b can only take a decimal values. So normally the syntax to declare a variable, we start with the data type of the variable, then the name of the variable. Then if we like, we can initialize the variable that's assigned some value to it. Also in C++, we have the octa and hexadecimal. Octa normally takes numbers and the base is 8. So the digit will be from 0 to 7. We normally use decimal numbers. Decimal numbers means the base is 10 and the digits are from 0 to 9. But also C++ can give us octa and also hexadecimal. Now, in order to denote an octa integer, we have to use a 0, a leading 0 for that. And also hexadecimal, we have to use 0x, a leading 0x. So for example, if I write a program and I want to print out 0xFFF, that will be the representation of 65535. Now here also, the decimal value of 8 for the octa will be 10. So I have a leading 0 here, 0, 1, 0. This tells me that the 1, 0 is an octa, not a decimal number. So 0, 1, 0, if I convert it to, again, decimal, it will give me 8. So we have a very short example here. We write a program here, and all we need to do is to print out OX, which means it's a hexadecimal. So what is the hexadecimal for FFFF? In decimal, that's there to be 65,535. Now, if we have 010, C++ knows that this is an octa value 10. So octa value 10 is 8 decimal. Also in C++, we have the double and float. Again, these are the decimal values. The difference between double and float is the number of decimal places. So we can see here, if we use, again, a double, we are going to get 16 digits, the decimal places, or sometimes we use the term precisions. And also, if we use float, we are going to get 7. So here we say that the double type values are more accurate because it gives us more decimal places than the float type values. So for example, if I see out 1.0 divided by 3.0, it will display 0 point, again, 3 up to 16 digits, the decimal places. Now, if I want to use floats in C++, we can add f. So 1.0f divided by 3.0f means this value is a float. Again, that will give us only 7-digit decimal places. Now, why call floating point? Here we say the float and also the double types are normally used to represent numbers that have a decimal or to represent decimal numbers. And why they call floating point numbers? because these numbers are stored into a scientific notation. So if we have a number such as 50.534, when it's converted into scientific notation, then it will be 5.0534 e plus 1, because we reduce the decimal place to the left. And this will be, its decimal point is moved, or we say floated, to a new position. So these are the numeric operators for C++. We have addition, subtraction, multiplication, division, and remainder. So the arithmetic operators for C++ is almost exactly the same as Java, Addition, subtraction, multiplication, division, and remainder. Now with Python, we know we have two types of division. When we have one single division, and we have also double two division. So single division gives us decimal result, and two slashes for double division give us integer answer, or a whole number. So again, these are all the arithmetic operations. So for example, 5 divided by 2, the answer will be 2. But anytime we divide a decimal value by a whole number, the answer will give us a decimal value, same as Java also. So 5.0 divided by 2 is 2.5. But 5 divided by 2 is 2. Now 5 modulus 2 means 5 divided by 2, the remainder. So if I divide 5 by 2, the remainder will be 1. Same as Java also. So we say the remainder operator again always is used if we divide two numbers and we want to know the remainder. So for example, if I want to check if a number is an even number, I'll just divide the number by 2. If the remainder is 0, then again, it's an even number. If the remainder is 1, then it's a odd number. So in this case, I'm going to use the modulus operator. Let's say the number modulus 2. What is the answer? Is it 0 or 1? And also we have what we call the exponent operations. In C++, we can use the power function to find a value raised to a power. So if we use the function POW 2.0 and comma space 3, normally the power function would take two arguments. The first value 2.0 is the base, and then the second value 3 will be again the exponent. So if we say power 2.0 and 3, it means 2 to the power 3. Power 4.0 and 0.5, it means 4.0 to the power 0.5. And this is the same as a square root. We know a square root means the power is half. So anytime I want to find the square root of a value, I can use the power with the base and then exponent 0.5. So let's see an example here how this C++ use the arithmetic operations and also the variables. So in this program, we will let the user enter the amount in decimal, which will represent dollars and cents. And then we are going to output the report in listing the monetary equivalent in single, dollars, quarters, dimes, and nickels and pennies. So what this program does is that we are going to ask a user to enter an amount, let's say $20.50. And we are going to say how many dollars we can get from that amount, how many quarters we can get, how many dimes, nickels, and pennies. So this means we have to use, again, the modulus operator. So let's see the program here first. Okay. So again, we start with our header file, number include IO stream. Then we are using the namespace std, which is the standard library file. This is our main function, it main. So we have our main function. Next, we ask the user enter an amount in double, for example, $11.56. We declare two variables, one for the amount that the user will enter. Sorry, we declare the variable, the amount the user will enter. Then we use our cin to allow the user to enter the amount. Now, when the user enter the amount, the first thing we're going to do now, if the user enter $11.56, we want to convert it to int. And we multiply by 100 so that we get 1156. So we know $11.56. It's like we have 1,156 pennies. So how many dollars I will get from 1,156 pennies? So that's the first thing we did here. We cast, so we have our static cast int. We change the cast again, the double to int. But before that, we multiply it by 100 also. So now we have all the pennies. So we know that $1 consists of 100 pennies. So we divide the amount by 100, and that will give us the number of possible dollars we can have. In this case, it should be $11. If we divide 1156 by 100, we don't get no remainder. We don't want decimal value. Our answer should be a whole number because we pass the value to a whole number. Then next, we want to know the remainder. So we have to use the remainder operator. So the remaining amount, modulus 100, that will give us the remaining. Then we divide that amount by 25. That will give us the number of quarters. Then we use the remainder operator again to get the remaining amount left. Normally, if we divide the value by 25, the possible remainder will be from 0 to 24. Then we divide again by 10 to get the amount of nickels. Then we modulus by 10 again. So the possible remainder will be from 0 to 9. Then we divide by 5, and that will give us the possible nickels. Then we want to know the remaining. The possible remaining, when we divide the value by 5, will be between 0 to 4. So we did that here. Then that will be the n. So the remaining will be the pennies that is left. Now we can see that we are using the variables, different variables. For example, we have the number of dimes. We declare it before we assign. We use anytime in C++, we need to declare our variables before we use it. So now we know the number of quarters will be in the variable name number of quarters. The number of dollars will be in the variable name number of dollars, etc. So here we came and print the output. So let's try and run this program. So we start the animation here. First, we go through the main method. They say we should enter any amount. For example, 1156. I'm going to enter 1167. So now, right now, our variable name amount, we have 11.67 decimal value. Then next, they say what will be the remaining amount after this statement executes. So let's see what statement they are talking about. Okay, that will be the static. Again, we can see, okay, so this is the static. So the amount will be 1167. Let's see if it's correct, because we multiply by 100 and we pass it to int. So that's correct. Then we move on to the next step. Now here they are telling us what will be the number of $1. So if we divide 1167 by 100, we should get 11. So let's see if we are right, and that's correct. Then next, we need a modulus operator, which means 1167 modulus 100 will give me 67. So if I divide 1167 by 100, the remainder will be 67. That's if I don't need a decimal value. And that's correct. So this means we are going to divide the remainder amount, shall we move one step, by 25. And that gives us 2, because 67 divided by 2 will give me 50, and the remainder will be 17. So the next, they will give us 17 as the remaining amount now. Then we're going to divide, we want to know the number of nickels. So we are going to divide 17 by 10. And the answer will be 1. And that means the remainder, again, will give us 7, because 17 modulus 10 will give us 7. Then we go to the next operation. And we have 7 divided by 5 is 1. So we have only 1 nickel. Then we move next step. We can see that the remainder is 7. So the remainder will be 2. And that will be the last final, because that will be 2 pennies left. So our program, let's go one more step. We want to see the display of our final solution. So this will be our display here. The number of dollars is 11, 2 quarters, 1 dime, nickels, and also pennies. And that's the concept here also. So first we change to 1156, because 1156 times 100, change it to int. Then we again divide by 100, we get $11. The remainder will be 56. Then we divide 56 by 25, we get 2. Then we have the remainder will be 6. Then this time we divide 6. And the remainder will be 6. Then when we reach here 6, remaining 6, if we divide 6 by 10, we get 0 point something. And we know 10 is 10 pennies, but here we have only 6 pennies. So that means that will be our last section. We're going to get in. The number of dollars will be 11. The number of quarters will be 2. And the pennies will be 6. We don't have no dime. We don't have no nickel. So also we have something called the overflow. Now, overflow means when we have a variable and the data type, let's say it's int, and int have a capacity of values that you can take. Long take larger, more larger value than int. Now, if the value that is taken is lesser than the value we are putting in, then we are going to overflow. So what we mean is that we declare variable, the data type is short, and then short take values. The highest values can take is 32,767, which means from minus 32,767 to positive 32,767. If I assign 32,768, that'll be too large. And that's the concept overflow. So here we say when a variable is assigned a value that is too large to be stored, it causes overflow. The next is arithmetic expression. So in C++, if I have this arithmetic expression, I can translate it into this form. So we know in algebra, if we say 4x, it means 4 times x. But in C++, we have to use the operator. So it will be 4 times x. Asterisk is multiplication. Plus is the same. And also parentheses work as the same as college algebra. I want to do the 3 plus 4 times x first before I divide by 5. So I can put it in parentheses. I divide by 5. Now 10 should multiply y minus 5. So I have to put the multiplication between 10. And also it should y minus 5 should multiply a plus b plus c. And that's what we have here. The answer we get, since all of them are multiplications, we just divide by x. Then plus 4 divided by x plus 9. You can see here 9 plus s. We want to put it in parentheses because we want to add it first, then we divide by y. So that will be the conclusion of this lecture. In the next lectures, we're going to discuss about some few examples on how, again, to run using C++ to solve some arithmetic problems. Thank you.